Welcome to the 9th program in operating system lecture series, and today we plan to discuss file systems. Now let's look at the various file types. The regular file, as I mentioned, in the ASCII format or in the binary format, and then directories are also files. We briefly discussed block special files, character special files. Now, in today's program, we are primarily concerned about the ASCII files. The beauty or advantage of the ASCII file is that they can be displayed and printed as is. One important property of ASCII files is that it can be displayed and printed as is. And another important property of ASCII file is that it can be edited with a normal text editor. And similarly, most programs use the ASCII text files as input and output. Another file type we discuss in the regular classification, we have binary files. Ordinarily, the binary files would look like a junk. If you print a binary file, it would look like a junk, a garbage, which won't make any sense to a user who will look at the printout of a binary file. But it does contain some structure to it, and only the program, the executing program, knows what that structure is and how to manipulate that structure. When we look at the printout of a binary file, it would look like a garbage. However, that is not a garbage. It does contain some internal structure to it. There is a structure associated with the binary file, and the executing program would know what that structure is. How it looks like, let's look at a diagram how the structure of a binary file looks like. We see here in the binary file, the first part of the file is the header, and in that header we see the magic number, text size, data size, BSS size, symbol table size, entry point, and flags. This is the header information. And in any executable file, we'll find that they are the part of the header is a part of the executable file. Okay, and we say then there is a text, data, then relocation bits, and sample table, and so on. This is how the structure of an executable file would look like, and it is a binary file. Another diagram, we see this part of the diagram, we have a header, and in the header we have a module name, date, owner, protection, size. It's an archive basically. This is number of modules, but they are not linked yet. We have a header, object module, header, object module, header, object module. This is basically a diagram depicts the structure of a binary file. Now let's discuss the various access mechanisms used in the file systems. Primarily, there are the two mechanisms with which we access the files. Number one is the sequential access, and number two is a random access. In the sequential access, we have to start with the start of the file and then read as the file progresses. In the random access, we can go any point in the file and read whatever we want. Let's understand the file access with an example. Think of a payroll program, and in the payroll program, let's say, is run once every month or once or twice every month. When the program is run, that program, there is some associated database with it. And when you start running that program, you cannot run that program selectively. The program will start from the beginning. Let's say we would see these are, let's say, 100 people for which the payroll is to be run. And the program will start from the beginning and then look from the database file, would pick record 1, calculate the salary, and then will go to the next, then will go to the next, and yet next. Okay. This means that that particular file will have to be read from the beginning to the end in order to run the payroll. Okay. Unless your payroll is structured that you can run a payroll for each person individually. While the random access will again recall the example of our airline reservation system. When the airline reservation agent want to make the reservation, would like to go at some particular point in the database file so that the information could be accessed or saved. While we have discussed various file types, now let's discuss the various access mechanisms used in the file systems. Primarily, there are the two mechanisms with which we access the files. Number one is the sequential access, and number two is a random access. In the sequential access, we have to start with the start of the file and then read as the file progresses. In the random access, we can go any point in the file and read whatever we want. Let's understand the file access with an example. Think of a payroll program, and in the payroll program, let's say, is run once every month or once or twice every month. When the program is run, that program, there is some associated database with it. And when you start running that program, you cannot run that program selectively. The program will start from the beginning. Let's say we would see these are, let's say, 100 people for which the payroll is to be run. And the program will start from the beginning and then look from the database file, would pick record 1, calculate the salary, and then will go to the next, then will go to the next, and yet next. Okay. This means that that particular file will have to be read from the beginning to the end in order to run the payroll. Okay. Unless your payroll is structured that you can run a payroll for each person individually. While the random access will again recall the example of our airline reservation system. When the airline reservation agent want to make the reservation, would like to go at some particular point in the database file so that the information could be accessed or saved. There are a number of system calls which are available in the operating system, and associated with each system call is a program. And these programs and these system calls primarily help us in manipulating the way if we want to create a file, if we want to delete a file, or whatever operation we want to perform on a file is handled with the help of system calls. Let's look at some important system calls in the operating system environment. For example, we see here create system call. Whenever we want to create a file, a new file, create system call will create an empty file. If we want to delete a file, the delete system call will be needed. Before we can use a file, we need to open a file, and open system call will help us. Close system call, if once we are done with the file, we'll use the close system call. If we want to read a file, if we want to write a file, append a file. Append is basically a variation of write, because append will append whatever we want to append at the end of the file. If we want to seek some information from the file, if we want to look at the attributes of a file, if we want to set the attributes of a file, or if we want to rename a file. These are just a few of the system calls used by the operating system. There are a number of more, but you can refer to your textbook or some additional study material that will go with this topic. Dear students, The next important issue from the user perspective related to file system is the concept of directories. And we briefly alluded in our previous discussion that directories are also files. And these files are basically, we create a structure in which we can store some other files. Basically, we would like to understand the concept of directory with the help of an example. Let's say you go to a library and you enter from the main door. Okay, main door we can call is the root directory. And while you enter in the library, you have number of sections: literature, one is magazines, other is let's say various sections in languages, biology. There are number of sections in the library, and then in each section there are number of books related to that. Now let's try to coincide with this example with the directory structure. We have a root directory. In the root directory we have number of subdirectories. Let's say users is a subdirectory, mail is another directory, news another directory, essays another directory, and then in essay, let's say subdirectory, we have multiple essays, multiple files containing different essays. What does this example tells us? The example tells us that directory provides us a mechanism to organize the files. Directory provides us a mechanism to organize a file by whatever criteria we want to organize the files. Now let's see. As I mentioned, directories allow us to that like files to be grouped together. Directories also allow us the operations to be performed on a group of files which have something in common. For example, if we want to copy a group of files from directory A to directory B, they provides us a mechanism to do that on one or one of their attributes. For example, directories also allow us the files to have the same file name. We'll describe this a little later. Let's say you have a file name AIOU. You can keep that file AIOU in multiple directories. If we don't have a directory structure, then in single directory you cannot have the same file with the same name. You cannot have that file twice with the same name. Okay? Directory structure provides us a mechanism that we can save a file with the same name in multiple directories. And a typical directory entry contains a number of entries. As I mentioned, that in each directory the number of files can be saved. About the structure of the directories, that all the data, file name, attribute, disk addresses can be stored within the directory. And also alternatively, just the file name can be stored in the directory and together with a pointer to a data structure which contains the other details. I would like to describe that with the help of a diagram. We see here in the directory structure, in this diagram we see two different structure. In the first structure we see here that we have a directory games, mail, news, work, and all the attributes of the directory entry are also within the directory. The attributes of the game directory, they are contained within the directory. Similarly, the attributes of the mail directory are also within the same directory, news and similarly work. An alternate structure could be, as we see here, that the name of the file is in that particular directory file, but the associated attributes, they are elsewhere. The data structure containing attributes can be somewhere else, not necessarily within the same directory. How we organize files in a directory, There are a number of alterations available. We'll discuss 3 here. In this diagram, we see here the system design A, in which we have a root directory, and all the users A, B, C, means A will have multiple files in here, B, C in the same directory, root directory. Another structure we see here is there is a root directory, and then we assign to user A one directory, another directory to user B, another directory to user C. And then A can have its file in his own directory, B can have its file in his or her own directory, C can have files in her or own directory. Yet another directory structure we see here is a root directory, user A, directory for user B, directory for user C. And we see here A has a file in it, B has another subdirectory, means B can create further subdirectories, and in that in the first level directory he can also have a file and a directory residing at the same level. It means, let's say the user B, the system gives a directory to user B, and then user B can have subdirectories in that as well as file in that. Means this will be essentially for the user, this will be for user's root directory, and he can have multiple directories, and then in these multiple directories the user can have files. Here we see we have a C, from the root directory user is given a C directory, and here user C is given creates within his own directory, user C creates another directory, and again user creates yet another level. We discussed the hierarchical structure in the beginning. We see here that this is how it is implemented. Another important concept in the file system is the path. Means in order to reach a file where the file is stored, you have to go to that path. If you don't use that path, you cannot access that file, because unless the system is told that the file is in certain particular directory, as we mentioned earlier, that the file system starts from the root, and in the root then there are some directories, then in each directory there are subdirectories, and then they can have subdirectories where the file is located. In order to reach that file, we have 2 ways to give the path to the system to know where the file is located. One mechanism is absolute path. In the absolute path, we give a complete path starting from the root in all the directories and subdirectories until we reach the file. That is one mechanism how we can reach a file. An alternative mechanism is a relative path name, and a relative path is basically relative to the current directory. It means in the directory you are currently functional. How it's done, let's look at in this slide. We see here in this absolute path, let's say we have a file somewhere in this file systems directory. We have a file, we give the absolute path C, courses, operating systems, file systems, and we can have file. This is the absolute path. In the relative path, let's say which is always related to the current working directory. Let's say you are in the current working directory is USR AST, and you have a file mailbox. Okay. In the absolute phenomena, if you want to copy a file, this mailbox file, and you want to make a backup of that, you will give CP, user, AST, mailbox, and you will give the absolute complete path. However, if your current working directory is /USR/AST, then you can use the command cp mailbox mailbox.back. It means you do not have to give the complete path in order to perform a file operation. You can do it with while you are in the current directory, you can do it with a simple state command. Now there are two other, whenever we create a file, there are, we call that dot and dot dot. Dot refers to the current directory and dot dot refers to the parent of the current directory. Whenever you create a file, these two files are automatically created. How the Unix file system is structured. Let's look at the diagram. In this diagram we see this / we call this is a root directory in the Unix environment. And in the root directory there is a subdirectory called bin, etc, lib, users and temp. Then in each directory we can have multiple files. We can have multiple files in bin, etc, and they can be file, they can be directories or whatever. We see here user. In the user directory of a Unix, we have a user Ahmed, Mujahid, Aisha. We can have as many users as we want in this user directory. Now, Ahmed will be allowed, whenever Ahmed will log in, will be pointed directly to Ahmed's directory. Whatever work Ahmed will be doing in his directory, in his space. Whatever Mujahid would like to do, will do within his space. And similarly, if Aisha wants to do something within her space based on the privileges and permissions. We briefly discussed earlier about the file system calls which we use to manage the file system. Similarly, we have system calls to manage the directory structure in a file system. And we'll discuss briefly some system calls, and as I mentioned earlier, to each system call there is an associated program. Whenever we want to perform an operation, we run the system call, that program is run, and the operation is accomplished. We see here we have the system call create. Whenever we want to create a directory, system call delete, we want to delete a directory, and directory can only be deleted if it's empty. If we want to open a directory and do some file operation, we have a system call to close a directory. If we want to read the attributes of a directory, if we want to rename a directory, if we want to link a directory with some other directories, or want to link some files with that particular directory, we can use link, or if we want to unlink that. We'll discuss some of these system calls in detail when we'll discuss the directory implementation. Today we primarily discussed two issues: files and directories from the user perspective. And in that we discussed file naming conventions, file attributes, file structure, file types, file access, file operations, directories, hierarchical directory system, absolute and relative path, and directory operations. This was all about the file system from the user perspective. From the operating system, file system designer and implementer perspective, we'll discuss in our next program. With this, we complete our today's program, and Allah Hafiz.